Good afternoon, everybody. Remember the last time we discussed refraction of light, and you can go to this web page, Vet Colorado EDU, and you can go to the app about bending light. Okay, I'm going to show you how this works. I turn on array, and I can change the angle of incident, and I can measure the angle of the refraction. You can use tools in order to measure exactly the angles, and then from the angles you can actually calculate the refractive index. So this is a very nice experiment to understand how refraction works and how you can find the angle of incidence and the angle of refraction. Okay. Now, another thing that you can change is the refractive index. Now, first of all, one thing that we need to know is that the higher the refractive index, the more the light ray will bend. So we look now at the right, and we can change the material, and let's see what is going to happen if we change the refractive index. And what we see clearly is a bending. The light ray that comes from the air that goes into the material is bending more. Okay. Alright. Okay, now we are going to start today with the critical angle and the internal reflection. Alright, some key areas that you're going to learn today. I'm going to talk about the critical angle and the total internal reflection. What we will do, we will state what is meant by the total internal reflection and the critical angle. We state the relationship between the refractive index and the critical angle. We will carry out some calculations. Okay, now how are we going to measure the critical angle? And we do that with an experiment. Okay, and look good at the pictures. We use a semi-circular block. We draw a normal line through the center. We shine a light ray along the normal to the center of the block. We continue to shine the light ray at the center and slowly move the light ray towards, and you will see that in diagram 1. And in diagram 1, what we actually do is, by changing the ray box, we change the angle of incident. Okay, and we're going to increase that angle until the light ray that is coming out will be refracted at a degree of 90 degrees. So that's in this case. Now, this is very important. When the angle of refraction is 90 degrees, we get the critical angle. And this is where we measure the angle between the light ray and the normal. This is normally an experiment that we do in the class, and it's very clear to see when the light ray shines on this semi-circular block when you will find the critical angle. Now, what do we mean by total internal reflection? Okay, let's go back to our first picture. Yeah, in diagram 1 the light is refracted. In diagram 2 we found the critical angle C, and in diagram 3 we increase that angle, the critical angle. Now what is going to happen when you go above the critical angle? Then all the light will be reflected. Okay, so looking again, diagram 1, the angle of incidence is lower than the critical angle. Diagram 2, the angle of incidence is exactly the critical angle, as the light that is refracted is at an angle of 90 degrees. In the third diagram, the angle of incidence is bigger than the critical angle, and then we get a total internal reflection. Okay, I come back here again to the same application, the Fat Colorado application, and I have now a semi-prism, and I'm going to shine the light on the semi-circular object. Yeah. Now, in order to change my angle, so this is figure 1, okay, that you saw. Now,